In June of 1816, snow fell across New England. Crops froze solid in the fields. Rivers in Pennsylvania iced over in the middle of summer. Thousands of miles away in Switzerland, a group of writers trapped indoors by endless gray skies and freezing rain decided to pass the time by telling each other horror stories. One of those stories became Frankenstein. None of this was a coincidence. All of it traced back to a single volcanic eruption on the other side of the world. An eruption so powerful that it didn't just devastate the region around it, it changed the climate of the entire planet for more than a year and quietly reshaped human history in ways most people have never heard of. This is the story of the year without a summer. It starts in April of 1815 on the island of Sumbawa in modern day Indonesia with the eruption of Mount Tambora. To put its scale in perspective, Tambora's eruption is estimated to have been roughly 10 times more powerful than Krakatoa decades later, and Krakatoa was loud enough to be heard nearly 3,000 miles away. Tambora is considered the most powerful volcanic eruption in recorded human history. Locally, the death toll was catastrophic. Tens of thousands killed directly by the eruption, and tens of thousands more in the following months from famine and disease as ash smothered farmland across the region. But Tambora's real historical impact wasn't local, it was atmospheric. The eruption blasted an enormous volume of sulfur dioxide directly into the stratosphere, where it combined with water vapor to form a fine haze of sulfate aerosols. That haze spread around the globe over the following months, forming a thin veil high above the Earth that reflected a portion of incoming sunlight back into space before it ever reached the ground. The effect was a measurable worldwide drop in average temperature, by most estimates around half a degree Celsius globally, but with far more extreme regional swings, especially across the northern hemisphere. That might not sound dramatic on paper. In practice, it was enough to disrupt the seasonal rhythm human agriculture had depended on for thousands of years. By 1816, the effects hit full force. In New England, farmers recorded snow in June. Frost killed crops in July. Some regions saw a hard frost in every single month of that year, something completely unprecedented in the historical record. Farmers who planted corn in spring, following the same calendar their families had used for generations, watched entire fields die overnight. The disruption wasn't limited to North America. Europe, still recovering from decades of war following the Napoleonic conflicts, was hit even harder in some respects. Crop failures across Britain, France, Germany, and Switzerland triggered the worst famine of the 19th century in the region. Grain prices spiked dramatically, and food riots broke out in multiple countries. In parts of Switzerland and Germany, records describe families surviving on foraged grass, moss, and even tree bark. Historians estimate the resulting famine and disease outbreaks contributed to hundreds of thousands of deaths across Europe. And then there's the detail that makes this story genuinely unforgettable. The one connecting a volcano on the other side of the world to one of the most famous novels ever written. In the summer of 1816, the poet Lord Byron rented a villa on Lake Geneva in Switzerland, joined by the young writer Mary Wollstonecraft Godwin, soon to become Mary Shelley, and her future husband Percy Shelley. They expected a typical Swiss summer of boating and outdoor excursions. Instead, they found themselves trapped indoors for days by constant rain, thunderstorms, and unnaturally dark skies, downstream consequences of Tambora's atmospheric veil. Bored and confined, Byron proposed a challenge. Each person in the group would write their own horror story. Most of those stories are largely forgotten today, but 18-year-old Mary Shelley's contribution became Frankenstein, or the modern Prometheus, a novel now widely credited as one of the founding works of science fiction as a genre. Without a volcanic eruption thousands of miles away disrupting a Swiss summer, one of literature's most influential monsters might never have been written at all. The atmospheric haze didn't just change the weather, it changed the sky itself. Sulfate aerosols scattered sunlight in ways that produced unusually vivid, intense sunsets across Europe for months. Some art historians have pointed to the paintings of J.M.W. Turner from this period, with their strikingly vivid, almost otherworldly orange and red skies as a possible visual record of exactly what people were seeing overhead during this time. The economic ripple effects went even further than famine and literature. In Europe, the sudden shortage of grain and oats made feeding horses dramatically more difficult and expensive. A German inventor named Karl Dreiss, looking for an alternative to horse drawn transportation during this exact scarcity, began developing a human powered two wheeled walking machine, essentially the direct ancestor of the modern bicycle. Some historians credit the horse feed crisis as part of what motivated Dreiss's invention. In the United States, crop failures across New England pushed struggling farming families to abandon their land and migrate west in search of better conditions, contributing to a wave of westward expansion into what's now the Midwest. Among the families affected by failed harvests in Vermont was that of a young Joseph Smith, who would go on to found the Latter day Saint movement after relocating to western New York. Historians note the crop failures as one of several factors that helped set that migration in motion. So, what actually caused all of this mechanically? It comes back to that thin veil of sulfate aerosols sitting high in the stratosphere. Because these particles sit so much higher than ordinary clouds or weather systems, they don't get washed out of the atmosphere quickly by rain the way lower pollutants do. Instead, they can persist for a year or more, circulating globally on high-altitude wind patterns, continuously reflecting sunlight and suppressing surface temperatures across the entire planet, regardless of local weather patterns on the ground below. This exact mechanism is why volcanic eruptions remain one of the most important natural analogs climate scientists study today when trying to understand rapid, large-scale climate disruption. Researchers have used the well-documented Tambora event to model what's sometimes called volcanic winter scenarios, and to better understand abrupt climate shifts caused by particles blocking sunlight in the upper atmosphere. It's even informed serious scientific debate around solar geoengineering, deliberately introducing aerosols into the stratosphere to counteract global warming, precisely because Tambora demonstrated on a global scale that the mechanism actually works. What makes The Year Without a Summer such a compelling piece of history isn't just the immediate human suffering it caused, though that suffering was real and severe. It's how far the consequences traveled, and how invisible the original cause was to nearly everyone experiencing its effects. Farmers in Vermont watching their corn die in a June frost had no way of knowing that a mountain on the other side of the planet was the actual reason. A teenage novelist in Switzerland, trapped indoors by grim, ceaseless weather, had no idea she was sitting inside the atmospheric aftermath of one of the largest explosions in recorded human history. One eruption, thousands of miles from nearly everyone it affected, managed to reroute crop yields, migration patterns, transportation technology, and the literary canon all at once, all from a single event most of the people living through its consequences never even knew it happened. If you like this video, like and subscribe for more.